Hello students, today we are doing lesson 5.5 on conjunctions. Okay, so conjunctions are when we're graphing two different inequalities and we're going to put them together and see where they overlap. So example 1, we're going to solve x is greater than 2 and x is less than or equal to 4. Okay, so the way we're going to do this is we're going to set up a number line with both those numbers on it. Okay, we need to make sure that we have enough room to kind of move around on the number line. So I'm going to make this number line like this. Okay, so I didn't really need all this extra. Okay, so now I have 2 and 4 both on there. So I'm going to go ahead and graph above the number line first to see what I have. So my first one, x is greater than 2, would look like this. Okay? And then this one, x is less than or equal to 4, would look like this. Right? Okay, so I'm going to overlap the two of those. So I want to see what answers would be true for both of these. So in this, that would be where they overlap would be right here. Okay, so I'm going to move that down and actually put that on the graph. So the 4 would be shaded in because 4 can be an answer for both of those. And then my shading's going to go this way. And then my 2 is going to be open just like it is right here. Okay, so this is my answer. Maybe I should have made that a little bit bigger. This is my answer. But now I'm going to, because it says solve up here, it doesn't say to graph it. Now I'm going to solve it by putting this together as one inequality. So I'm going to have 2 and 4. See, I'm writing it on the graph so that you can kind of see it. And this is greater than 2. Oops, I'm sorry, I wrote that wrong. Okay, sorry about that. Okay, so I'm going to put x in the middle. That's what I forgot to put. Okay, x in the middle. Oops. X in the middle. And then my 2 over here, my 4 over here. There we go. Okay, so x is greater than 2. So the opening's going to go open for the x. And then the 4, x is less than or equal to 4. Okay, so that's how this is now my answer. Okay, so I'm pretty much put together these two problems and I solved it kind of with a graph. You could also do this without a graph, but I like you to be able to see it with the graph. Okay. Okay, now let's go on to example 2 and get another example in here in case you did not get that one very well. Okay, number 2 is going to be x is equal to 4 and x is less than 6. Okay, so here's my, I'm going to make this, give myself a little bit more room. Okay, I want to make sure 4 and 6 are both on there and a little bit of wiggle room in here. So I'm actually going to do 2, 3, 4, 5, 6, 7, 8. Okay, now I have enough numbers on there. Okay, so let's go ahead and graph x is equal to 4. That's just a dot, right? That means x is equal to 4. And now if I graph x is less than 6, that would be an open circle and everything to the left. So now what I want is I want where these two go together. So I'm going to put just that part that I circled onto the actual graph. So this is going to be a solid circle and an open circle and the line in between. Okay, so see how what I'm graphing? I'm graphing where they intersect, where they're both at, and they're both equal to that. Okay, and now I'm going to write out that equation. So this one's going to look a little bit different than the last one. I'm still going to kind of do it the same way, is I'm going to put an x in the middle, 6 on this side, and 4 on this side. And now I know x is less than 6 because of where I shade it. So this could be less than 6. And on the graph, x is greater than or equal to 4. Okay? So this is how I write that one. Okay? Okay, next one, example 3. Okay, example 3 is, once again, a little bit different. The book tries to put in a lot of different examples for you that you're going to run into in your assignment. Okay, so now when I graph this one, same thing, drawing a graph, but this time I have all the way to -3, so this is going to be a lot of numbers. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, now, for this example, I'm not going to write in all those. Now I'm going to draw above it each one. So x is less than or equal to -3, and then x is greater than or equal to 7. Okay, if I needed to put on the graph where they intersect, do these graphs intersect at all? No, they do not intersect at all. So what this is called is an empty set. It means there is no answer. So the book writes it like this. That's called an empty set. You can also write something like no answer, or no solution might be a better answer. Okay, and that's your answer. There is no answer because they do not intersect anywhere. Okay, I think there's only two more examples. Okay, example 4. So that was a different one, right, where they don't intersect at all. Now, example 4 is, once again, another type of problem. X is less than or equal to 5, and x is less than 0. So in the top two, we had one was greater than and one was less than on all the top 3. Now we have where both of them are less than. So let's look at what this one's going to look like on our graph. We need to go from 0 to, I'm going to start with -1, and then 0 to 5. 1, 2, 3, 4, 5. Oops, 0, 1, 2, 3, 4, 5. Okay, so above again, so that I can know what I'm doing, I have x is less than 5 would look like this. X is less than or equal to 5, and x is less than 0 would look like this. Okay, maybe I should have extended this line a little bit. Okay, so where do they intersect? They intersect right here, right? And what am I going to put on the graph for that? Okay, I want to make sure that everything will work in both equations. So this is going to be an open circle and everything to the left. Okay, and that's where they intersect. So if I pick a number in the shaded area, like -1, that -1 should work here. -1 is less than 5, that's right. And up here, -1 is less than 0, that's right. Okay, so when I'm writing my answer out, it's going to be x is less than 0 is my answer. I don't have, this one doesn't have one where there's 2 numbers in there, or x is sandwiched in between 2, because x is just less than 0. So where these two intersect is just x equals 0. Okay? Okay, and then the last example, example 6. I'm sorry, it's not example 6, it's example 5. Let me redo that. Oops, example 5. Okay, example 5 says solve 2x plus 5 is less than or equal to 11, and -3x is greater than 18. So it wants to know, when are both of these true? That's kind of what we're doing with conjunctions. We're trying to find out two problems and merging them together, saying when are they both true. Okay, so I'm going to solve both of these. On this one, I'm going to subtract 5. And I get 2x is less than or equal to 6. Then I'm going to divide by 2. And that tells me x is less than or equal to 3. Now I'm going to move over to this inequality and divide by -3. Remember, when I divide by a -3, I need to flip my sign. So I flipped my inequality sign. And now these are the two problems that I'm trying to find out. So I'm going to show you this one, how to do this one without a, a number line, how to solve it. So you don't have to draw a number line every time. I'm going to put x in the middle, and then I'm going to put the number that's the least on the left. So -6 is the least, and the one that is the most on the right. So 3 is the most. So I'm using these two numbers, right? I put the least on the left and the most on the right. Okay, so because the x and the 3 are in the same order as it is up here, that one's easy. Okay, I just take the sign and make it the same way. Okay, because it's in the same order. If I was to cover up that -6, I can't do that on this screen. But if I was to cover up that -6, then this would just look like the same problem. X is less than or equal to 3. But on the other side, where x and -6 are, those are not the same as right here, because x is on the left and -6 is on the right. So I'm switching those around. So when I flip those around, I have to also flip the sign. I need to look at that x point is on that side. And this would be my, where my x is. My x is less than -6 and less than or equal to 3. Actually, now that I'm looking at this, it looks wrong, right? Because these look funny. They're not both going the same way. And that's why you need a graph. So if that looks wrong like that, you probably want to say, hey, wait a minute, let me do a graph real quick. So I'm going to do a really quick graph without even putting a bunch of numbers on it. And I'm going to say, okay, this was x is less than 3, less than or equal to, and x is less than or equal to -6. Okay, so do you see where they intersect here is over here. So this is going to be one like that last one was, and it is only going to be the x is less than -6. And that's my answer. So I could figure that out from here also, because they're both less than. I should have seen that first. And if they're both less than, then I want to go with the one that's the lowest, which is -6, because that's where they're going to intersect. And that would be my answer. Okay, so on these, you do not need to show graphs, but graphs are what help you solve them. So what they're wanting you to show on your work is this part, okay? The x is less than -6 is your answers. Okay, that's it for today. Tomorrow we'll be doing disjunctions, which are a little bit harder.